In this lesson, we're going to review the different ways to factor any polynomial. We can do this by asking 4 easy questions. First off, with any polynomial, you must consider, is there a greatest common factor? After determining that, we look at it and see, is this a trinomial? If it's not a trinomial, look and see, is it a difference of 2 squares? If not, are there 4 terms involved? Once you decide which one of the 4 questions to go into, then we'll do a further discussion on factoring. So let's look at our first question. Is there a greatest common factor? What we're looking for is a problem similar to 3x squared plus 6x. Right? Is there a greatest common factor? Well, yes, I can see there's a 3 can go into both terms, and x can go into both terms. So as a review, you're going to write this as your denominator. To come up with your final answer, you write the denominator, parentheses, and then actually do the division. 3 divided by 3, x squared divided by x. I get x. 6 divided by 3 is 2, and x over x is 1. So looking at a greatest common factor, I factored out of 3x and left with x plus 2 in parentheses. Question number 2, is this a trinomial? Well, my first one was definitely not a trinomial. Remember, a trinomial is in 3 terms, ax squared plus bx plus c. Okay. If it is indeed a trinomial, we're going to look and see if the lead coefficient is a 1. If it is, we can use our shortcut. Right, so let's do an example like that. Let's do x squared plus 8x plus 15. Okay, I can see that this is a trinomial. There is no greatest common factor. My lead term is a 1 right here. The shortcut is let 2 numbers multiply to give you 15 and add to give you an 8. Well, I know 3 times 5 is 15. 3 plus 5 is 8. So my final answer, I put them in parentheses, x plus 3 times x plus 5. Okay, so that's factoring using the shortcut. Let's look at an example now where the lead coefficient is not a 1. Okay, that would still be within my trinomial. Maybe 2x squared plus 7x plus 3. Okay. First I look, is there a greatest common factor? Nope. It is a trinomial. My lead term is not a 1. I have 2 choices. I can factor by grouping, or I can factor using the box. And I'll show you both in this lesson. To factor by grouping, you take the first times the last. First times last. So 2 times 3 is 6. I need 2 numbers that multiply to give me a 6 and add to give me the 7. Okay. I'm going to use 6 times 1 is 6. 6 plus 1 is 7. And that 7 came from right here, the middle term. So I'm going to break this middle term into 6x plus 1x. 6 plus 1 is 7x. And the reason I do that is because now I have a 4-term polynomial that I can factor by grouping. I group the first two together and the last two. The GCF in the first two is a 2x, and I'm left with x plus 3. There is no GCF in the second group, so it's just a 1, x plus 3. And for your final answer, you bring what's outside the parentheses together, 2x plus 1, and what's in the parentheses, x plus 3. This is factored by grouping. It works every time. You never have to change any symbols or signs, anything. Okay. Let's do the same thing now with the box method. Factor by the box. So just as a quick refresher, you put the first term in the first box and the last term in the last box. Okay. So draw up my box here. And let's use our same polynomial, our same trinomial. 2x squared is my first term. 3 is my last. I still multiply first times last. 2 times 3 is 6. So I still multiply to get a 6 and add to get the 7. All right, and it is 6 times 1 and 6 plus 1. So in this box goes the 6x, and in the last is the 1x. And if you look, 2x squared plus 6x, my first row, is the exact same thing as my first group of parentheses. My second row, x and 3, is the same as my second group of parentheses. So the two methods are directly related. It's just a different way of presenting the material. With the box method, I am going to pull the greatest common factor, 2x. Pull the greatest common factor out of the second row, 1. Pull the greatest common factor out of the first column, and the greatest common factor out of the last column. And there's your answer, 2x plus 1 and x plus 3. Right, the box method works almost every time. The only time you have to be careful is if when you're determining your middle terms, if they are both negative, then you need to make sure they're both negative in your answer. All right, so those are our methods if you have a trinomial. Let's look now if you don't have a trinomial. Is this a difference of 2 squares? 2 squares would be the first term is a square and the last term. And you're subtracting. When you factor this, you get a plus b times a minus b. Right? You're going to square root the first and last term and put a plus sign and a minus sign. For example, let's do 9x squared minus 1. Okay. There's no greatest common factor. This is not a trinomial. But what I do notice is that I can square root the first term, and I can square root the last. So the square root of 9x squared is 3x. The square root of 1 is just 1. So you put those in your two parentheses. In the first group is plus, and the second group is minus. And that's your answer for a difference of 2 squares. Then our last method for factoring is if there are 4 terms. All right, let's say this is my problem. 5x cubed plus 10x squared, 3x plus 6. Okay, I've listed out here the 3 ways to look at it. You're going to group it by the first 2 and the last 2 terms. So I'm going to come up here and put my parentheses around the first 2 and the last 2. Part A, look just at the first 2 terms. What's the greatest common factor? Well, I can pull out 5x squared, which leaves me with x plus 2 on the inside. What is the greatest common factor in the last 2 terms? I can see they both have a 3 in them. So I'm going to pull out a positive 3, which leaves me with x plus 2. To write my final answer, factor by grouping, I write what's on the outside, 5x squared plus 3, and the inside parentheses, x plus 2. The reason we do that is this x plus 2 is in both the terms, so I can factor it out, leaving me with the 5x squared plus 3. And that is your final answer. So refer back to this sheet as we move on, dividing, multiplying, and simplifying rational polynomial expressions.